Warm round of applause for Santiago.
Cool. Thank you very much, everybody. Hope you're having a great day at Dash. Thank you so much for joining me so that I can share the story of how we are currently migrating the decades of critical data to the cloud. But before we start, I wanted to ask all of you, can you raise your hand if you have been part of a cloud migration project? Wow, lucky us, right? Because a cloud migration is basically one of the most challenging journeys that you can have in a cloud architecture. Why? Because you have a lot of unknowns. When you are migrating from on-prem to the cloud, you have decades, you have a lot of years of software that has been built on-prem that most of the times nobody knows how the architecture looks like. I will share before one very simple example that happened to us. So we manage a lot of data. I will show you a little bit more about that in a second, but one of the main challenges we saw when running databases in the cloud is that databases need to be patched. They need to be patched automatically, right? Now, if you build your data processes in such a way that they are not resilient, then they will stop, they will break. And this is one of the main things that we saw when we started migrating to the cloud. And we were breaking the number one principle for running workloads in the cloud, which is everything fails all the time. But first, let me tell you who we are. So dx.one is basically a subsidiary of the Volkswagen Group. We receive a lot of data coming from all the dealers, and we are responsible for providing digital sales and after-sales products for the different brands, for Skoda, for Audi, for Porsche, for Volkswagen, MAN, and so on and so forth. We are taking the business of B2C, B2B. We do also a lot of data management and analytics and also CRM. Now, to put you an example, we are receiving a lot of data from the dealers. That means that if you bring your car to a German dealer, we know that you were there. Mostly, we know the whole history of your data. We also know the whole history of your car. Why? Because we provide solutions to the dealers, for example, for booking appointments. That means if you need to have a revision of your car, 50,000 kilometers, 25,000 kilometers, 30,000 kilometers, you will book an appointment in our system. We also provide systems to the dealers so that they can manage the repair and the maintenance of the vehicles. And they can interface with the customer in the case that there is something broken. So imagine, for example, that you went for a 20,000 kilometer maintenance, and then suddenly the brakes are broken. There is an automated process that will put you in contact with the dealer, and you as a customer, you will be able to approve it, and then they will, of course, they will send you before the cost, and then they will repair the brakes for you. We also provide sales dashboards so that dealers can also dynamically adjust the price. So if we are a very good customer of Volkswagen, Audi, Skoda, they will know about that because of the products that we are providing to them, and they will be able to give you a very good discount of your next car. Now, all this technology that I showed you before, it was basically running on-prem, somewhere in Germany, yeah? And we started that migration project to modernize how we are running things in the organization. And this is how our architecture looked like before the migration. You don't need to understand this architecture. I'm not expecting that from you. It took me a couple of weeks when I joined the company last year to be able to understand what was happening here. But one of the main things is that one very good architect told me some time ago, you don't need to worry about how many boxes you have. You need to worry about how many arrows you have. And this is a perfect example of that because our architecture scaled based on the data dependencies and processes dependencies. But that was not only our main challenge. Our second challenge was about that we didn't have a consistent staging. Some applications were running in development, some applications were running in development and production. There was no automated cleanup in place. That means that we had decades of historical data that was sitting there without any automated process to clean up. Apart from that, we were not automatically patching or updating our servers and our databases. Data pipelines, as I showed you before, they were breaking every time that we were restarting a database. That means that every time that we wanted to restart a database, we needed to send a message to the owners of those databases so that they know that we will restart the database so that the data processes are being paused. Monitoring was embedded in the code, and this is actually my favorite one. Inside the data pipelines, there were monitoring procedures that were sending emails to very, very specific people saying the data pipeline failed, the data pipeline processed 50 gigabytes of data, the data pipeline processed only 50 records. Of course, we had no infrastructure as code and no automation. And the list continues. And that's why we started our project to migrate to AWS. So we started by assessing which type of migration we wanted to do, and we decided that we wanted to go for the rehosting. So rehosting means it's just a lift and shift. We wanted to prioritize time over modernization. So we wanted to lift and shift, and we did a re-platform only when really, really necessary. I leave you the QR code. If you want to take a look at the 7 Rs, that's a very, very interesting article from AWS. And that took us to the target architecture in the cloud, with the following goals. First, we don't want to adapt the business logic, because that will mean a major refactoring. Second, we are only re-platforming only when really, really, really necessary. We are going to enrich the infrastructure with infrastructure as code, because we wanted to set up the foundations so that we can automate. And last but not least, we wanted to invest also in observability from day one. Why? Because if you don't invest in observability from day one, you will pay a much, much higher cost afterwards. And that took us to our first job, which was, let's segregate our one and only on-prem environment into more than 30 AWS accounts. So we started by creating our AWS environment for the data ingress and also the data egress. Remember, we are processing large amount of data coming from all the dealers in Germany. Our data storage is basically the central account where we are processing and storing the main data. We have a lot of different products that they have each one of them their own AWS environment. Of course, we have a shared network, centralized network, because we want to secure the network in a central way. Shared services and also workspaces. Last but not least, we also have our observability in place. Now, we are here in a tech conference, so let's take a look at the technology behind that. When it comes to data ingress and data egress, we are relying on S3. We are relying on a lot of proprietary protocols that are deployed in different types of servers. They are quite old, and we are running those in EC2. And one example of re-platform, instead of deploying a mail server, we started using AWS SES. When it comes to data storage, we are relying on RDS. So that's also another re-platform that we decided to do. Good decision, bad decision, I will tell you at the end. Each and every data product has a different architecture. So some data products, they have RDS. Some data products, they are using RDS together with containers and together with OpenSearch. Some they have APIs, some they don't have APIs. When it comes to the workspaces, all our employees, they are given a virtual desktop so that they can access the data and they can also run queries, basically, on the databases. Now, we started, but also paused it, and we continue after the first migration, the integration with HashiCorp boundary. Why are we using HashiCorp boundary? Because we want to have an abstraction layer on top of the databases so that we don't need to do user and access management inside the database. And same story for the servers. Of course, we are not provisioning AWS on our own. In the Volkswagen Group, we have AWS landing zones. We have different teams that are providing AWS as a service. And they provide also a lot of different platform tools. For example, Concourse for CI/CD, GitHub, JFrog, and CloudGuard for compliance. Last but not least, observability. We are integrating with Datadog, with the native AWS integration. And we are funneling all our logs using Data Firehose. Now, observability was very, very fundamental for us for having transparency because we had no transparency before starting the migration to the cloud. And one of the first things we did is that we defined an internal maturity level for observability. First level means basic AWS integration. So just integrate AWS CloudWatch metrics. Yeah? Funneling logs to Datadog, alerting on critical metrics. So one of the things that we did, because the organization was not mature enough with observability, we collected from all the different data product owners just the top 3 critical alerts. Keep it simple. Instrumenting APM, that's a little bit more advanced for us. It will be done in the future. And that will set up the foundation for real-time application security monitoring and also cost management. So in a nutshell, we went for the first 3, for the first migration. Now, standardizing how we integrate with Datadog helped us to integrate more than 35 AWS environments in just some days. What does it mean? We are integrating with Datadog by using Terraform. And this Terraform is being run in automated CI/CD pipelines. And not only that, but the architecture to integrate to Datadog is based on using agents only when necessary, but also using the AWS native integration, and funneling the logs using Data Firehose. So why are we funneling the logs only using Data Firehose? Because we have lambdas that are enforcing that the logs are being tagged. So remember, always you need to have a very, very good tagging hygiene in your Datadog environment. Now, that was only the start, and we also defined some key measures so that we can prevent losing data, and also the project sustainability, because we are a small company in the group. That means we don't have that much money. We also need to ensure that we are treating our resources in a very, very cost-efficient way. The first thing that we did is develop a migration runbook. So in order to develop this migration runbook, first we defined the toolset that we were using for the migration. Basically, we were using pgdump, pgrestore, mydumper for MySQL databases. We put everything together into shell scripts that are orchestrating the whole migration, and we use the AWS S3 storage gateway to transfer the dumps from on-prem to the cloud. Now, it was very, very important for us to first define what a runbook actually means in the organization, and second, to be very, very clear who's the responsible for each and every activity that we have in the runbook. And also test it, and test it. Yeah, because a migration is a very, very, very complex exercise. The second key measure that we did is about monitoring ingestion of data. Without ingesting data, we have no data to process. So that's very clear. So we really needed to monitor the critical parts of our data ingestion. How do we do that? We basically monitor how much data we are receiving. In average, we were receiving about 200 to 300 gigabytes of data per month in the different servers, and they were transferred to S3. So what we do here, we are just showing the evolution of the amount of data that we have in S3. We also need to monitor the availability of the different servers, because if the servers that are responsible for ingesting data are not available, then we don't have data. And this is an example of a monitor that we developed, which is essentially alerting, in the case that there is a deviation with regards to 250 megabytes. Of course, it would be great to have this a little bit more dynamic, but 250 megabytes is the amount that we have as of today in average. But that's not all, because you need to monitor the availability of all the different components that you have in your data process. So we are using Talent, for example, for data pipelines. We are also using Navicat. Navicat is a paid version of dbeaver, for example. We are also monitoring some legacy Pascal code that we have. Yes, we do have Pascal in our company. And those type of processes are fundamental in order to be sure that we are processing the data correctly. In some cases, we are monitoring APIs. So where we have APIs, we are doing synthetic tests. And we also implemented database APM in basically all the databases. Database APM is a service that it is expensive. Yes, if you look at the product catalog of Datadog, it's one of the most expensive products that they have. But the visibility that you get from that product is amazing. We are also monitoring the database replications and workspace. So let me dive into the database APM. With database APM, you can monitor and you can evaluate, for example, the duration of the queries. You can also evaluate the throughput of your database server. So how many queries your database server is capable of processing per second. You can also see in a very, very nice way how much time is being spent in the different type of operations. So for example, how much time you are investing into I/O, how much time are your database is spending into commit logs, for example. And this takes me to one challenge that we had. I have a very simple example. Here, we have a data critical process in the database that requires that the queries cannot last more than 300 microseconds. Why? Because we need to process a lot of data on a daily basis so that the dealers are able to get that data on the next day. So we went into Datadog APM. We started looking at what is actually happening. Why do we have more than 1,000 microseconds in average per query? And we found out that we were essentially making update statements in single transactions, which is actually an anti-pattern. So you can tweak the parameters of the database, or you can group multiple update statements into one transaction, and then you will significantly reduce the amount of commit logs. But we were able to see this only with Datadog in a couple of minutes, and we were able to jump directly afterwards into solution mode. Another example is the query recommendations. We have a lot to improve in terms of our database workloads, and we know that. But having a tool that is able to recommend us on real time and tell us which are the queries that are the slowest, which are the queries that are taking most of the time to commit logs, for example, that's very, very, very nice to have. But now we are looking into performance. The next step is the costs. So you can see here very nicely how our costs exploded over time. Most of the costs that you see here are related to RDS. So you can see in this picture that our IOPS and the storage actually scaled a lot in the last months. So IOPS is basically a way to measure how performant is the storage layer of the database. And we needed to scale them because we needed a lot of performance during the migration. And we scaled them that much that this will be the number, the amount of money that we will have to pay in the case that we will continue in that way. That would mean $90K per year only for IOPS, which is kind of crazy, right? So how can we solve this? Or how did we find this out? By using Datadog APM, outside of the migration times, we saw that the CPU is quite constant, yes, between 0, between 10, sometimes 20%. But the IOPS were never above 4,000 IOPS. During the migration, because during the migration we were doing a lot of indexing, we saw that the IOPS were increasing. But the CPU was not really increasing. So this takes me to the conclusion that our workload is very, very, very storage intensive, but it's not at all CPU intensive. Now, came to our mind, how can we do this? How can we optimize this in a much more automated way? And it's quite simple, because RDS allows you to change the storage and also to change the IOPS during runtime without the need to restart any database. And that's quite incredible. And this can be done in Datadog with a workflow automation. A very, very simple workflow automation that is essentially triggering a Lambda. That Lambda is retrieving the value of how many IOPS we should have in a dynamic way, of course. And then it can modify the RDS instance by increasing or decreasing the IOPS, or increasing or decreasing the storage. So very, very simple workflow automation that can be done in a matter of half an hour, 1 hour maximum, and will save you around $90,000 per year. Now, all the previous points were very technical, but in my organization, we had a real transformation with the cloud migration. Why? Because there was a lot of fear for transparency. Once we started speaking about observability, there was a fear of finding out which systems are working, which systems are not working. There was a need of resiliency in the data jobs. So with observability, we were able to see that data processes were stopping and why, and that triggered basically the need for fixing those. Automated backups of our business critical data. Remember, on-prem, we didn't have those. In the cloud, we implemented those. Observability through dashboards and alerts. So that brought the next level for us in an organization to be able, for example, to put a dashboard in the cafeteria, right? To be able to provide that transparency to everybody of which things are working and which things are not working. We went from ticket-based approach, meaning I have a problem, I open a ticket, somebody else is taking care of, to a self-service way. I enable you with dashboards, I enable you with alerts, I enable you with tools so that you can take care of your own problems. We were able to discover also a lot of inefficient database operations. And, there are a lot of aspects, changes, and stress in a cloud migration project, right? And they are technical and not technical, and that takes me to the main point, which are the takeaways, which is you need to accept chaos in a migration. There is no project management technique that will ensure that your cloud migration will be on time. No way. I have seen that multiple times. Only re-platform when it's really, really, really necessary. In our case, we decided to re-platform all the databases from deploying them in servers to deploying them in a database as a service like RDS, and we face limitations with RDS. Now we are in the process of fixing them by deploying some databases in servers. Why? Because there were some special configurations that we were doing even on the operating system level that are just not working in RDS. One of the things that I didn't say anything about this, but this is one of the point ones that I will have actually invested in the beginning, into a data catalog. You need to be able to know what you have in the organization before starting the migration. Integrating observability from day one is a must. Why? Because if you don't do this, you will have to pay a bigger price afterwards, because it will just deviate from what it should be. Controlling costs, for example, with automation workflows. So that's one way. There are multiple ways to control the cost, but please, 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 always with automation. Transparency through dashboarding. Remember, going from a culture of something is not working, I open a ticket, to a culture of I provide you the tools, I provide you the dashboards, I provide you the data, so that you are empowered, you are enabled to fix your own problem. And last but not least, lift and shift is not the end. After a migration project, you definitely need to start investing into modernizing. And as you can see, we have still a lot of work to do. So we are hiring. If you want to join us, feel free to reach out to me, and I will direct you to our website, our different positions that we have, and I also leave you some literature here that I really like. So with that, thank you very much for your time. Enjoy New York, and I'm open for questions.
If you've got questions, please head to the microphone in the center of the room. Can you tell me what the Pascal code does? Can you tell me what the Pascal code that you still have does?
Oh, it's actually doing a lot. So we have basically two master data systems. One is called legacy, but it has been called legacy for quite some time already. And then we have our new master data. Basically, all the data that is coming to the system is being processed in these two parallelly. And then there are some data products that are relying on the legacy one, some data products that are relying, so minor set of data products that are relying on the Pascal one, and the major amount on the new one. We are also, of course, in the process of modernization. We want to really get rid of the legacy one, yeah? Hopefully in the next months.
Any questions from the audience?
Yeah, thank you for the talk and for sharing. At the beginning of the talk, you were mentioning that one of the goals in the architecture should be to reduce the errors in the architecture diagram that you share. I don't know if you have any stories or any insights on how that came out in the cloud migration, like what were the key aspects of the migration to the cloud that helped the organization to reduce the amount of dependencies and how we achieve that?
Yeah, so that's a very, very good question. So if I can summarize it, if migrating to the cloud help us to reduce the amount of data dependencies that we have between the components, the answer is no, not the lift and shift. That will be part of the modernize part of, because that's basically business logic, right? Those dependencies were built by us, and we are the owners of those dependencies. The main objective of the cloud migration for us was first to set up the base ground, yeah, the foundations, to have a compliant infrastructure, so that we can start reducing those dependencies. Actually, those dependencies, they played us very, very hard when migrating, because you cannot do a step-by-step approach, right? So you can basically prepare everything in the cloud, then migrate the data, and you basically end up having a big bang. Why? Because you have those many dependencies. So that's a drawback, yeah, and that's something we'll start investing after we go live with the first migration.
You mentioned observability was built in from day one, and yet you said there was a culture change around fear of transparency. Can you expand on that a little bit more?
Yeah, absolutely.
It seems like there was some.
Yeah, that's a very good point also, absolutely. So what I meant with that is that before we built observability in the way we built it, we were building observability inside the code, and only very specific people were being notified about metrics, about alerts. That creates a culture of, I will put everything here, basically. Nobody will know what's happening. And if there is a downtime, I will jump in and try to fix it ASAP so that nobody notices that. Yeah. So we went to that approach, to an approach of having an open dashboard where everybody can see what's happening, potentially also pushing it to put it in open spaces. Yeah. And of course, if you do that, that creates automatically a lot of more questions. Yeah, you have your board, you have your management board, you have everybody basically that is asking questions. Why? Because people are naturally interested into what they are seeing in the dashboards. In my case, there was a little bit of fear towards that, but we are building that together with everybody so that there is no culture of blame. There is no culture of, I'm afraid of what can happen. There is more a culture of, hey, yeah, things happen, things fail all the time. And I always say, we are not doctors, we are not on a surgery room, we are just configuring and programming machines, right? So it's not that bad anyways.
Who's got the really hard questions?
And I step up to talk about dashboards. How do you get people, is it one dashboard? I have a big government customer that all of these cool features are not available in Datadog GovCloud, but that's okay. But I have 150 organizations across government trying to find the holy grail of a dashboard. Is it one dashboard, executive scorecards? Do I want to see storage capacity? I can't pinpoint people on certain dashboards. Is there a number of dashboards that you use? Do you use SLOs? What kind of metrics? Is there like a, is there golden signals type dashboard for technical and then cost for executives?
Yeah. I call that the art of dashboarding, basically.
It takes too long.
It's very hard, and it takes some time. It's basically the same as with the alerts. So you can configure as many alerts as you want, but if you make your Slack channel or your email inbox or your Teams channel noisy, people will just start ignoring it. So coming back to the dashboard, it depends on the audience. So of course, I will always suggest and push towards having an availability dashboard. You want to know that your systems are up and running. I was also extremely happy to see that now we have in Datadog the status page. Yeah, that's also a very, very good progress in that direction. Then, of course, you have the dashboards that are relevant for the engineers. So for the teams that are owning data products, for the teams that are owning those databases, for the teams that are owning those data pipelines, they will want to have a lot more fine-grained information. But in any case, my position on that is always to provide templates or to push the teams to use the already provided dashboards by Datadog so that they can start creating their own dashboards. There is no perfect dashboard. I always say that to all the teams. However, you need to build that over time and you need to adapt it based on your needs. But of course, for sure in an organization, I will always say that you need to have an availability dashboard, you need to have a cost dashboard, and not only about the cost of your resources, but also the costs associated to Datadog, because I have also seen costs associated to Datadog exploding. And of course, you want to have a dashboard where you are able to filter in a very good way the logs. So those three dashboards are the ones that I usually recommend, of availability with the SLO, with the metrics, and so on. But then you need to jump into a more fine-grained where you can actually search the most relevant logs in your organization.
Still have a few minutes for questions. Yeah, please head to the microphone.
So you were mentioning about index and IOPS relationships.
Yeah.
So I wanted to know much more. Actually, we have very similar experience about IOPS actually costing much more than the instance class costing. So I want to know if there are more indexes, that means IOPS going up or down. Or what about the CPUs? And
So when the more indexing you have during a migration, the more IOPS you will need. But don't forget that after that, each and every update or insert statement that you have in the database will, of course, increase the IOPS. So you need to be careful with that. So we got to discover that. So as a small footnote, I'm a cloud architect, and all the workloads that we are migrating are coming from data engineers. Usually, it's very nice to see in an organization the difference between the data engineers and the people that are actually developing the infrastructure and the architecture, because we care a lot more about that because it's exploding the cost. Now, you need to take care and you need to be very careful that you are not indexing that much. You need to be careful how you are treating the update and the inserts. And last but not least, you need to be careful about the number of transactions that you are having into the database. So the more you can group transactions in the commits, basically, to the database, the better it will be. for the IOPS, because then you are relieving load from the database. But again, that's an exercise to do after you discover that. Before we didn't know that. Now we know it, and now we need to go and look into all our queries that we have in databases, and first analyze if we need to change them, or even second, analyze if RDS or a transactional database is the solution for us. Because you can also tell me, yeah, you can also use Redshift, for example, if you have a lot of OLTP operations. But that's something that we are discovering right now. Yeah? Right now we are focusing only on the lift and shift, and afterwards we will start modernizing and seeing where we go with our tech stack.
What's your favorite part about being a Datadog ambassador?
Wow, I think of course, the unlimited access that we have to Datadog, that's for sure. So being able also to influence how things are happening, Datadog, also to share what we are doing, the possibility also to write. I also like a lot writing, yeah? Writing articles, writing blog posts, and so on and so forth, and sharing knowledge. Yeah? That's the most important part of, I think, being an ambassador, and trying to motivate others.
Any last questions for Santiago? All right. Well, thank you very much for your talk. One more round of applause.
Thank you very
please.
much.